This is a class of improper integration, and here we test the convergence of two important improper integral. The first one is integration 0 to 1 by root under x minus x squared dx, and the second one is integration 0 to pi by 2 dx by e to the power x minus cos x. Okay, now we use two tests for these two improper integration. The first test is comparison test. This is very important and very useful test of improper integration. And the second test, this is most favorite and hot favorite test, this is mu test. Okay, for the first problem we use only mu test. Okay, now we first go for the first improper integration. Here it is clear that this integration can be written as integration 0 to 1 dx by root x into 1 minus x. Right? Now if we put x equal to 0, then the lower portion is 0, so there is an infinite discontinuity at x equal to 0, and if we put 1, then there is also so for the lower portion. So 1 is also an infinite discontinuity of this integral. So we split the interval of integration, like this is integration 0 to half plus integration half to 1, and we name these two integration as the first one is I1 and second one is I2. So for the first integration I1 we get, this is integration 0 to half dx by root x into 1 minus x. Right? That is here f of x, this is equal to 1 by root x into 1 minus x, and here only one point of infinite discontinuity at the lower range, that is at x equal to 0. So we use the mu test for the first case. Okay, here we take x minus a to the power mu, this is equal to x minus 0 because here a equal to 0 to the power half, that is we take root x. Now we calculate the limit x tends to 0, root x into fx means 1 by root x into 1 minus x, and this is given by limit x tends to 0, 1 by root 1 minus x, this is equal to 1, and this limit is finite, non-zero, not infinity, so this is non-zero, finite, non-zero and finite. Right? So we know that by mu test integration a to b fx dx is convergent if and only mu this is equal to less than 1. So we say that since mu this is equal to half less than 1, by mu test I1 is convergent. Right? So we get I1, this is convergent. Now for the second case, that is for I2, we get for I2, here we take, this is b minus x whole to the power half. Okay, and here b, this means b means 1, that is 1 minus x under root, and now limit x tends to 1 minus 0, root 1 minus x into fx, and this is given by limit x tends to 1 minus 0, 1 by root x, this is also 1. So this limit is also not equal to 0, not equal to infinity, and by using the limit test of using the mu test of second case, integration a to b fx dx is convergent if and only mu less than 1. Since mu this is equal to half, here mu also this is equal to half less than 1, so by mu test I2 is also convergent. Okay, and since I1 and I2 both are convergent, so this integration must be convergent. So the answer of the first integration is this is convergent. For the second integration, 0 is only one point of infinite discontinuity. Why? Because at the upper range, that is at pi by 2, if we put here pi by 2, so we get e to the power pi by 2 minus cos pi by 2, this is equal to 0, so this is not 0. Not 0 or not undefined. Okay, not undefined. This is a finite definite value. So pi by 2 is not an infinite discontinuity. Infinite discontinuity. Here only one point of infinite discontinuity, which is at x equal to 0, because at x equal to 0 e to the power 0 means 1 and cos 0 this is also 1, so 1 minus 1 is 0, that is 1 by 0, this is undefined. Okay, now we test for at the point 0 only, and for this integration if x this is equal to 1 by e to the power x minus cos x, and we take gx this is equal to 1 by x minus 0 whole to the power 1, right? Now we make a limit x tends to 0, because here a equal to 0, lower limit 0 plus 0, fx by gx. We want to use comparison test of limit form, so we have to calculate the limit fx by gx at x equal to the lower limit a, right? So this is given by limit x tends to 0 plus fx by gx means x by e to the power x minus cos x, and clearly this is of the form 0 by 0, and so we use L'Hospital rule, and using L'Hospital rule we get limit x tends to 0 plus 1 by, this is derivative of x is 1 and derivative of e to the power x is e to the power x plus sin x. The derivative of cos x is negative sin x. Now if we put x equal to 0 in this function, so we get this is 1 by 1 plus 0 means 1, that is not equal to 0 and not equal to infinity. So we get non-zero finite limit or non-zero finite L, and we get the case 1, not the case 2 or not the case 3. So we use the comparison test, and the first case we get integration a to b fx dx and integration a to b gx dx both together convergent or divergent. Now we know the behavior of this integration 0 to pi by 2 dx by x minus 0 to the power 1, because this integration, for this integration we use this result. By using this result we say that here mu this is equal to 1, and we know that integration a to b dx by x minus a whole to the power mu is convergent if and only mu less than 1, that is if mu greater than 1 or mu equal to 1, then this integration must be divergent. Okay, so we say that this is the divergent integration, and from the comparison test we here say now both the integration together converge or together diverge. This is shown here. Okay, and since we proved already this integration is divergent, so this integration 0 to pi by 2 fx dx is also divergent, and this is our problem 2. Okay, so we say that this is the divergent integration. So our answer is the first one is convergent and the second one is divergent.